Hello everyone, my name is Liana Maisara binti Mazlan from Bachelor Medical Imaging Cohort 14A. So today I'm going to present about Automatic Exposure Control AEC. Okay, so what is actually Automatic Exposure Control, or we can also call as AEC? So basically AEC is a device used in radiographic and also mammographic imaging system. In radiography, this AEC is placed in front of the image receptor IR, while for mammography, it's located underneath the image receptor. So for further information about this AEC, once a predetermined amount of radiation is transmitted through a patient, then the X-ray exposure is terminated. So here is the example of AEC that I put in the slide. Okay, now so we already know about this AEC, so let me discuss about what is the main purpose about this AEC. So basically, AEC is a very good at producing consistent levels of exposure regardless of the patient size and pathology. Its the other purpose is to automatically stop the exposure if a certain amount of radiation is detected. We need to know that less repeat can cause less patient exposure. It's also important to use proper steps regarding patient position and centering, detector size and selection, collimation, and also the type of image receptor itself. Alright, so next we will discuss about the type of radiation detector used in AEC. So radiation detector is a sensor used to convert radiation into electricity. So there is two types, which are phototimer and also ionization chamber. So phototimer is a first generation of AEC system, while ionization chamber is the most common use in AEC system nowadays. Okay, so now let me look at phototimer first. So phototimer is earlier generations, and it is exit type device because the detector are placed behind the image receptor IR. So before the radiation is measured by the detector, it must exit the image receptor first. So the component in this phototimer is fluorescent screen that used in converting X-ray into the visible light. And then we also have photodiode that used to convert the visible light into the electricity. And then lastly, we have timer circuit that act as capacitor and exposure terminating switch. Alright, so next for ionization chamber. So ionization chamber is a commonly used today. It's entrant type device because the detector are placed in front of the image receptor IR, and then the radiation can interact with the detector just before it interacting with the image receptor. And then the components for this ionization chamber is hollow cells, which the air will be ionized by the radiation, and then it will create electricity. And then next, it also have timer circuit that function same as the timer circuit in the phototimer before, which is act as capacitor and exposure terminating switch. Alright, now so let me look at the difference between the phototimer and ionization chamber. So as you can see, here is the example, and I hope that it can help you to understand more about the concept of this radiation detector. Alright, so the most common difference between these two is the X-rays are converted into electricity is automatically stopped after the predetermined radiation dose is reached. And then these ionization chamber are less dedicated and also less accurate, but then they are less likely to fail compared to the phototimer. Okay, so without further ado, let me discuss about minimum response time, MRT. So this MRT is the shortest exposure time that the system can produce, and the minimum response time for AEC system is usually longer than the other radiographic timer. And then this MRT also depends on a few factors, which are high speed receptor system that are used, and then the high power generator, and then the small anatomical parts are imaged with the AEC, and also the high MA stations that use. It is important to know that when the MA too high, and then the AEC cannot stop because it is fast enough. And then lastly, we need to use lower MA and then lower KVP for the small patients. Alright, so that's all from my presentation. Thank you for listening.